uh, you will have to just memorize these keywords. So uh, it is one of the technique I have tried in my MPhil, uh, not in MSc, but later on I yes, then I did my MPhil in 2009. So in 1 week before the exam, I started reading all the things, and then along with that, I kept on making these small keywords and their meaning, and then you can connect them all these keywords. Okay, I hope you can see the PIC microcontroller 16C6X7X. Um, so this is somebody Suresh uh, who uploaded the video related to this. These are the engineering people. So we have seen earlier that PIC microcontroller, the architecture that we have seen earlier, and what it has. Uh, Basic is ALU, then it must have memory, it must have uh, central processing unit or arithmetic logic unit. After that, it must have bus structure, it must have um, other registers, program counter, stack pointer, and timer or oscillator. So these are the main 4 to 5 main ingredients of any processor microcontroller. If you remove the, if you subtract the memory, then it is a microprocessor. If you add the memory, it becomes microcontroller. If you have some display uh, along with the microcontroller, then it will go into microcomputer. So this is a kind of a framework we have. All these processors, microcontrollers are having I/O ports, so input output. Now the communication can be serial or parallel. In the serial or parallel communication, you can have a variety of protocols. Okay, that is called as handshaking. So these peripherals will talk to each other. Now these protocols are developed on the basis of the synchronization or asynchronization. Means the speed with which these fellows are going to talk to each other. If the speed is equivalent, the communication will be very fast. If it is not equal speed, then one of them has to send the clock pulse, and on that clock pulse, the communication has to be carried out. Okay, so it will send a pulsating signal, and then using that pulse, the data will be transferred. So you have studied all these things, even like amplitude modulation. So when you do amplitude modulation, you have your things uh, which are in the 20 hertz to 20 kilohertz, which is audible sound, but it is not traveling towards longer distance. So because of the sound waves. So what you do, you convert these sound waves um, into electromagnetic pulse. Still, you are not able to send this electromagnetic pulse easily in air. So because the dielectric constant of the air is such that it destroys all these waves. So you have to understand that uh, if the frequencies are very much higher, then it is possible to send the signal. Okay, so some sort of material properties you have to understand, even though it is a electromagnetic communication. And then what you do is that you impose your signal on that carrier wave. So and then even in case of decoding, what you do, you want to now subtract the carrier waves and only take out the sound signals. So how do you do it? It's a tricky thing, right? So if you just remember inertia, it is a kind of inertia is a based on the gravity. right? There is no instantaneous response by the body, massive body, to the applied force. Right? So you must have seen so many experiments because of the inertia that people put um, paper on the glass and then they put coin on it, and if somebody pulls very fast, the coin falls inside the glass. If you pull the paper slowly, the coin will also come with it. The coin is acting like sound signal, and the speed with which paper is withdrawn is like a carrier wave. So it is carrying all the signal. Now you have to have such a device which is little bit slower. So what will happen that it will just try to capture the slower pulse or slower signal, and in this process automatically it is subtracting the high frequency pulse, right? So this is the thing that you have to understand, and once you understand, you can do communication with different things. You can do lots of experimentation. Even you can bring lots of things. Even the we are in, sitting in the wa- in the closed room. Okay, still you are able to hear the sound. So now can we use such waves, the amplitude modulated waves or any other waves, to see through the walls? These are the new experiments which are going on. Maybe you will come to know about terahertz, that at this region you can see through many things. I mean, terahertz, there are lots of materials have their own signature. So instead of using X-rays, people want to use terahertz, but it is difficult to generate terahertz and detect the terahertz. It's not easy task. The way X-rays can be produced and detected, or amplitude modulation, FM, all these waves can be produced. Microwaves can be produced and detected in radar application. So same way, if we have many things, we are surrounded with many electromagnetic waves, and how we are going to detect. Okay, so all this story is coming from basically the protocol, the handshaking, and the communication way uh, by means of which this microcontroller, microprocessors are talking with each other. Okay, so you can see in order to understand a small part like how the microcontroller is going to communicate with the other microcontroller or computer, uh, we have all these things. We have seen that IO port, input output. Now input output is also going to serve uh, uh, different thing like sending the signal to the display, okay, or recording device, um, taking the instruction from the keyboard or mouse. Nowadays we have a screen. So I hope you are understanding that all the ICs that we are going to study, so-called smart ICs, they have a CPU, they have a bus architecture for data and memory recognition, memory address. Then they have a arithmetic logic unit, that is say we say brain or central processing unit, uh, memory, address bus or bus structure, IO ports, and along with that it will have some registers or protocol also, that uh, along with hardware they will have some instructions. Okay. So now you can see on the screen that 16CX and 16C7X are 8-bit microcontrollers. Okay, means whatever data is given, that has a length of only 8 bits. Okay, the funny thing in this case is that the address bus are somewhat longer than the data bit. maybe 14 bit, 16 bit. So in this case, PIC microcontroller. So in previous case, what we have seen, address bus is also 8 bit, and the data bus is also 8 bit. In some case, we have seen that there are 16 bit addresses, like 8051 will have a 16 lines, so it is a 16 bit address bus and 8 bit data bus. Okay. In microprocessor, you will see even it is a 8 bit or 8 bit 16 bit. So 8 bit data bus, 8 bit address bus. In 8051 or advanced version, it will be 16 bit. In PIC microcontroller, 8 bit data bus and 16, uh, 16 bit or 14 bit or 13 bit address bus. So the length of the address will
Hello,
be,
sir.
yeah,
So,
yes.
what is the advantage of having a higher bit microcontroller?
That we will see later on. Uh, See, what will happen, higher bits are actually, there are certain bits, certain programmers, because everybody is learning. So, those who have a little bit curiosity or some maybe kind of a naughty behavior, these people used to, add certain strings, and they used to manipulate. So, actually, we can have a variable length of the address bus depending upon the microcontroller, but the processing power is only 8 bit. That it is just taking 8 bit. Now, people found out there are two things. One is the security, and second is the um, converting means you have to accommodate maximum number of parameters or the things that you are surrounded with, like color you want to accommodate, you want to accommodate some number, you want to accommodate some alphabets, you want to accommodate certain languages, right? So earlier English was the only language that is being accommodated, and then the compiler used to understand only that language, right? So whatever you write in that, people now thought of, no, no, we don't want to use English, now we want to use our own language, our own symbols, right? So you can see, like dollar symbol or our rupee symbol. So if you want to accommodate all these things, you will have to expand the bit size. In 8-bit microcontroller, you will be able to accommodate 2 raised to 8 uh, parameters or things into it. Okay, in the form of a data. So even if you have an instruction, say 2 raised to 4 or 2 raised to 5 instructions or 2 raised to 8 instructions, but when you talk about the data, the microcontroller or the microcomputer need to know what is that. Okay? Sometimes people used to manipulate all these things. So to avoid such things, you can have a initial bit in the form of a security code, okay, or some sort of encryption code, and after that you will get the data. So it prevents this unwanted intrusion or all these things in your operations. As the advancement of this internet, when people started using internet, and automatically certain people were playing to destroy each other's not destroy, switch off each other's computer by means of some program, and so it was like a game for these people, but unnoticingly what they did, they have created certain virus, that this virus used to restart the PC. Okay, so the person who used to win, his program used to reset the other people's PC. So it was like LAN, in the land area network, but uh, automatically this information leaked out to one of the fellow, and then people thought that okay, we can write such kind of program also. So it was initially like breaking your horizon or thinking out of the box. But instead of improving the system, it had created trouble. That is the thing. So everything is now in the form of zero and one only. Okay. Even our money is also in the form of zero and one if we do all the online transactions. What we are doing, for us on machine, we see the number or we see the values. We see some uh, thing in the language, our own language also. But when that information is transferred, that is in the form of zero and one code only. So this is the thing that is troubling us. Okay. So even I have not fully understood because on terms of timing scale, I know that if I want to process 8-bit data, I require 8 clock pulses. If I want to process 16-bit data, then I will require maximum 16-bit at least to means maximum depends on the other parameter, but at the most, if 16-bit data is there, I require 16 bits to process them. If I have a 8-bit data, I require 8 clock pulse. So if it is 64-bit, nowadays our mobile phones are 64-bit. So you assume that we require 64 clock pulse to process or to do addition, because what will happen? Um, Number A and number B both are of 64 bits. You want to add them. One of the uh, in one of the bit addition, there may be generation of carry. Again, I have to consider the addition of carry into the higher level bit. So by default or anyhow, I have to utilize 64 clock pulse. So no matter whatever is the speed of my mobile phone, 1.6 gigahertz or 3 gigahertz. 3 gigahertz I have not seen any mobile phone, but 2 gigahertz up to 2 gigahertz you can see. So you consider you are using 64 bit is a kind of a thing that I don't want. I want to speed up the process. So if it is better that if I have a coding such that I can name or I can code certain things with this much number of bits, then what will happen? It will help us to speed up the processing, data processing. Watching video, listening MP3 file doesn't require any processing. There are separate ICs. Only CPU, what it does, it guides the memory that you have to transfer the data. Means it gives the connection between the uh, that audio processor or video processor and the data, and they work independently. The data flows from memory to the audio processor, and you can listen the MP3 file. But when you want to add, subtract, you want to do logic operation on the data, it is going to be the task of the processor, and then it has to work very carefully. You must have seen sometimes watching videos, it may skip some frames, and then you must be hearing some sound also. Uh, so there are chances that this processor may miss out some of the bits and jump on the some different frames. There are some scrolling capacity, so you can jump from one time scale to other time scale. You can directly jump onto some intermediate position. So these operations are there when only the microcontroller will take part. Otherwise, it will bypass all these things. So when you start increasing the size of your data, so to store one word like A in 8-bit, there is ASCII code. So maybe 65 or 68 is the code. When you press Alt on your computer, Alt 68 number, it will give you this thing. Simply, it is going to give you numerical value, ASCII code. So these tables are available. How A is understood by the machine. So when we press keyboard A, actually what we are doing is that we are like pressing the combination of Alt button and some number. Okay. So even if your one key is not working, you have a if you have a code, then by pressing Alt button and 0 to 9 numbers, um, you will be able to type all the things. Okay. So the expanded keyboard is actually to help us that you need not to press all the time A and this. So this is American standard code. But then 8-bit, after 8-bit you have 16-bit. So security and accommodation, these are the two main purpose behind the 64 or 32-bit program. Okay. So these are the main two things. Rest of the things people can find out. So these microcontrollers are RISC processors and use Harvard architecture. This PIC microcontroller. So earlier we were having CISC processor, 8051, 89C51 and 89. It is from the Atmel. Now these microcontrollers are RISC. So over there, what was the difference? That Intel's microcontrollers were made up of only PMOS or NMOS technology. Now Atmel processors are made up of CMOS. CMOS, why CMOS is preferred? You can accommodate lots of uh, transistor. So the transistor density increases with the use of CMOS. Okay, BJT is the basic one. So transistor density is one of the parameter. Secondly, the power consumption in the case of CMOS is very less, right? So this thing you must have studied in your TY basic, because we want to save our power. We want to make our battery long lasting. So whichever device is going to work, it has to have a capability to consume very less power. So the current flowing in CMOS, even though it is switched on or off, it is in some microampere current, and the fan out response is also very good. Okay? So that you have to understand. So even though we are working on the system which is having millions of transistors, why these transistors are used, that also we have to see. So that was the advancement. In this case also, this fellow is working on, and the software architecture was CISC in this 8051 and Atmel processor. But here it is a risk reduced instruction set. So we have seen the basic 16C6X microcontroller, PIC microcontroller, is having only 35 instructions. Okay, and 18 pins. 61, the 16C 61 PIC microcontroller is having only 18 pins. I will show you somewhere. I have it. Okay. So if you see this, so PIC 16C61, so it has, sorry, not 16, 18 pins only. Okay. So using this, and in MSc, those who are having electronics, even in colleges and in university, electronics communication and electronics, we have this thing, programming or all this. So these people are using this PIC microcontroller to program, and they are using this basic PIC 18 pin PIC, and the kit is also available in the market. It is not costing more, so I don't know. It is some 25 to 100 rupees processor, or 16 rupees, I don't know. But I know it is less than 100. Veda people are providing all this, and it is also around 400-500 something. So one can just connect it to the PC and burn the program and see how the PIC microcontroller is working, and keep the source code. right? And can bring out the this thing product into the market for different purpose. Okay, so you need to know what are the requirement by the industry or the people, uh, and then like you want to develop some attendance system using PIC microcontroller. So, or you want to create something which will automatically ring the bell when the lecture is over. So, there is no one dedicated person to ring the bell always. That he has to just stay like a timekeeper. Instead of that, you can have a simple circuit, and whenever 50 minutes lecture is over or 1 hour lecture is over, you program it, and then it will ring the bell. It can ring two types of bells. Like for MSc, you have a lecture of 1 hour. In colleges, you are having lecture for say 50 minutes only. Okay, so one lecture used to be 50 minutes. In schools also 40 minutes, or they have their time domain. So in such cases, you can develop all these things and you can write program so that it can ask whether this is college lecture or this is MSc lecture, and then accordingly the program will work, and it will synchronize with the regular clock, and every day it will function automatically. And people are providing all this. So they write small program depending upon the need of need of all the people or the schools or industry, and they try to provide the small solutions, cheaper solutions, because the cost are very less. As you go with the higher, mm, maybe I have not shown you, but when you go with the advanced thing, even we have a device. I have paid 30,000 rupees for a very small motor. This motor is used if you go into the market. Same dimension motor is available at 25 rupees in Lamington Road. But uh, this particular motor is used in that UVV spectrometer, and it came from Singapore, and it costed me 30,000 rupees. So there is a lots of things. So what is the special in that motor, one has to see how controlled. There are stepper motors, so more number of steps, the cost will go on increasing. But from the outside, the box is like it is just motor which is available in the market. Even in the printer, there are many motors, so you can take out one motor and you can utilize it like the thing. But these are the things in the market, and then you have to consider these are the opportunities in front of you. Why I'm telling all these things? Because after MSc, uh, you will move in a directionless manner, and still you are doing MSc, so there is no pressure on your head. As I told, every time I tell all the batches, the moment you get your final result, then for result, uh, you will realize your value. So, okay, somebody has asked some question. Uh, Let me check. Yeah, this motor is somewhere. I will send you the photograph in our WhatsApp group, right? And then because I have kept it somewhere, so right now I cannot show you, but maybe next lecture I will show you how the motor appears. But you have to see that when you are studying and when you are, you know, pay the fees and all these things, you make sure that it gives you better thing, or it helps you to stand confidently when you go out of the classroom and in the open space. Okay. So, anyways, this is PIC microcontroller. I can share more time on different things because I know once you read all these things, you have to do it your homework very carefully, because I used to ask tricky question, at least 50% questions, 25% questions based on utilization of your knowledge. So then I can give you hint that I have given you the idea last time also. What is the logic diagram um, which is used to compare the two numbers greater than or smaller than or equal to? The way you do addition subtraction of two numbers using the full adder, similar circuit is used to compare the two numbers. Okay, I have given you the idea that instead of adding the two number using the adder subtractor, why can't you use op amp as an adder or subtractor, the circuit that you have used in MSc, right? If you divert the addition program to the op amp, and if you do the addition, there is no need of clock pulse. You give the number, immediately you have got the answer. Okay, but here full adder, half adder, you have to be clock pulse. Similarly, I have asked, uh, this is the simple thing that all these processors are 8-bit microcontrollers because they process 8-bit data. Suppose I want to add or subtract or multiply 16-bit data using the 8-bit microcontroller. How will you write or how will you proceed? I want only algorithm and flowchart, no program. You have to add or subtract 16-bit data or multiply. And since you are in MSc, see this way the IIT peoples are trained. Okay, they are also using the same reference book. They are using the same content, but uh, unless and until the questions are given in a such fashion, you will not start thinking. I want to add 16-bit or 32-bit number in 8-bit microcontroller or microprocessor. Okay, so these are the things. So as I told you that the PIC program memory is 12, 14, 16-bit wide. Not told, I told you about for the bus. Okay, so memory bus is there. So it is 16-bit wide or 13-bit wide or 14-bit wide. There are processors. Similarly, PIC program memory is 12, 14, 16-bit wide. So this program memory is this much bit wide, means in this case, what is happening that PIC is having its own program memory, or it is a EEPROM. Okay, so where all the instructions and the meaning of the instruction or the loop structure is written. Okay, and it is a separate program memory, so it has a separate bus to communicate. For the data is written into the separate memory location, and it is controlled by the 8-bit address line or 16-bit address line, depending upon the size of the memory. Okay, the size of the memory means 1 GB, 2 GB. The way we say, I have a pen drive, so how many 16 GB है या memory card है 2 GB, same. But in that much big uh, sized memory unit, the data which is stored is just 8 bit. So you can just think of a kind of a house. Okay, one may be the small hut or small house, but only 8 people are staying in that. There can be a tower, say some 40 floor high or 60 floor high, 100, 100 floors high tower. But uh, in that tower there may be so many rooms. Okay, these are the different address location. From the ground it is 00, and the top may be 2 raised to n, whatever is the width. Address 2 raised to 16 if it is memory. And in each flat, anyways, only 8 people can stay. That is the size. So this is 8 bit, the meaning of, so data is 8 bit. People staying in the home is like data, so it is 8 bit. And the size can be anything. So it can be a small hut, or a small building with 2 floors, or it can have a tower of 40 floors or 60 floors. Okay, so this data memory of PIC is 8 bit wide. Now program memory is different thing. It is separate. It is like you can consider some government official body or this thing, and then there may be 12 people or 14 people. So this way, if you imagine, you will be able to reproduce it. That in case of PIC, the program memory is 12, 14, 16 bit, and the data is 8 bit only. Now this kind of information is not provided for our other microcontrollers. So you can try to find out what is the program memory size. In the rest of the means the previous versions of microcontroller, the program memory is also of similar size, 8 bit only, and it can have address, different address. Okay, uh, in some cases the in the address particular memory location, half part is permanently utilized by the microcontroller for storing the calculated things or program and all these things, and it is not user accessible. Only small part of the memory is user accessible, but the entire memory is of 8 bit wide only. Okay, so the program memory is automatically 8 bit wide, because it is the same memory is used to store program, also the data uh, added by the user. Okay, but in this case you will have a separate memory to store program, and uh, to store data you will have a 8 bit memory. Okay, so now this is like PIC is an embedded controller, so it has some predefined functions. Embedded, when the word embedded comes, you have to just start thinking that eh, it is like live system. Embedded, the main thing is that all the embedded systems are live OS. Okay, the moment you switch on the button, it doesn't take time to load the files into the RAM and start function. It is sort of a permanently loaded file in the RAM, right? These are called as NAND RAM. And the moment you switch on, uh, what will happen, that its interrupt, various interrupt will give the signals that the interrupts will behave like a sensor. So it will tell the processor that you are in this mode now. And the simplest example is washing machine. So if the knob is towards washing mode, the moment you switch on the button, even you can do the experiment. You put all the clothes and everything, water, water. You put the knob on the washing mode and press the button. It will immediately start washing. It will not wait for your instruction. If you put the knob on the spinning mode and you switch on the power, it will start spinning. Okay. Instead of that, for your mobile phone, when you switch it off and then switch it on, you have to wait for loading the files into the RAM. That is the difference. So it is very fast working. This is the meaning that the fellow is trying to convey. It is an embedded controller. So once you burn the program, now it will start functioning wherever it will first try to gain the information from its interrupt signals and sensors, and then immediately it will start functioning. So PIC instructions are highly orthogonal, non-overlapping or mutually independent. PIC instructions are almost same, hence all PIC registers and addressing modes interchangeable. Okay, so uh, there is a one thing here. In our previous case, we have seen there is a accumulator, there is a register B. Okay, in microprocessor, accumulator or register A is same. In the and the register B, C, D means all the processing is done in the accumulator. Okay, so you cannot you can access the accumulator, but mathematical or arithmetic logic operations are done in the accumulator. In the higher order, there used to be register B called as working register also sometimes, and it used to help in arithmetic operation. Now here, as it suggests that there is no any reservation kind of thing uh, in case of registers that accumulator will perform this. So there will be a kind of a register. Let me check because it is little bit confusing sometimes. Uh, okay. So, okay, what it trying to say is that PIC instructions are same and all PIC registers and addressing mode interchangeable. So uh, each register is identified by its particular address, but you can take any two registers. Um, in previous case, what you are supposed to do whenever you want to do any operation, you have to move the content of any register to register A, and after that it is to work. Okay, so in this case what is happening that you can directly transfer the content to the arithmetic logic unit and the working register. Okay, so you need not to have an intermediate register A to transfer, receive and send the data. So earlier it was like accumulator or working register, then register A, then it goes to other units. Even if you want to store the data into memory, in microprocessor, what you are supposed to do that you have to load HL pair and then store the content from that to the register A, and then you do the mathematical operation. Once the result is available, that result you have to transfer it to register A, and then you have to send it to uh, the different memory uh, this thing, locations. But here, if you process the data like the multiplications, you set three register A, B, C. C acts like a counter. You store the number to be added in register B, and you clear the register A, and then you do add B always, and you decrement the number. Now the content of the register C, that you can directly store to the memory location. Okay, then content of the register B you need not to store because it is there, but the content of the register A, that then you store it. So otherwise what you will have to do that first you have to store the content of the register, means the answer of the multiplication. Then you have to transfer the count which you have placed in register C, that it has become 0. Okay, otherwise this is the cross checking. So you have to transfer that content of the register C to register A, then from that register A it will go to the memory. So that kind of operation is avoided, and thereby you save the time of the multiplication process or other things. So register, any these register can directly stored into the memory. The opcode register addressing mode are mutually independent. Okay, means uh, they are not mixing with each other. That is what. So um, when we write some program, whatever we store, it is categorized in three things. One is instruction, the code. Okay, the machine code that we write. Machine code will have three things uh, that the programmer has to understand. First one is the instruction, that is also starting from 00 to FF. Second one is the data. The data is also from 00 to FF. And the third one is the address. So address, even it is a kind of a 4 bit in hexa decimal world. 4 bit means 0000 or C100, that is the address. So that is broken into two parts, C1 and 00. So first you write LSB, then you write MSB. So date, instruction, data and address of the memory location. These three things are coded with the same wording, 00 to FM. Okay, and therefore many time when you write program, since we know, I will just ask you simple question that you study the program with the address location C100. I just change it to D100. Okay, that now you have to store the program in D100, and D100 will have a memory, and people who mug up the program will write for the C100 because that is what there in their notebook, and the program never runs because I always go with a D100. If I am asking like that, I can go with D200 or anything. So you understand that when you are writing program, you must know what is the flowchart, you must know what is the algorithm, and then you know what is the machine code you are using, what are the address, what are the data, and what are the instruction you are using, and how you have to put it. So in this case, what is the opcode register addressing modes are mutually independent. Means uh, as you go with the advancement, the machine code is changing. Now you directly say register A, register B, and then machine is converting that command into its machine code. Okay. So when you say move A to B or you say register A, yeah, so using keyboard, actually you are typing register A and some number. So it will directly store that number into register A. For microprocessor to do this operation, what you have to do is that 3E. 3E is the code to move immediately the data. Then it will ask for the number. So from keyboard you have to give the data. 3E is MVIA, means you immediately move something into register A. Okay. So from the small keyboard available. But now in the case of microcontroller, what you do, that register A, you name it, and then you give the value. That data will be stored in register. How means how user friendly the programming is becoming. Okay, so that is the advancement in the new versions of this. Um, so if you learn the programming with a 8085 microcontroller or microprocessor, the C programming or the higher level of programmings are very easy to understand. So because then you know the logic, you know the flowchart, so you can learn any language. You, if you are familiar with the low level languages like 885, HTML, using that notepad to write. So these are the things. So that's why you have to put little effort in understanding these things. But the moment you are familiar, you are happy. I don't know this year we are going to study 8085 or not, but I have insisted that one should start learning 8051 at least, and then C programming is there anyhow. So you'll be learning all the numerical process and all these things. My advice will be that you must take it little bit seriously, because if you learn today, in future it will help you in all the aspects. Means no matter whether you go astronomy or nuclear physics or even in the electronics, there is a lots of demand in the market for those who can do or who can create something new, right? Because that capability of the person is tested always. So once you say I have done this thing, they will automatically, give you the preference. And this is what we have seen earlier also. This is what means for the many students, those who did kind of a programming thing. they were given the opportunity first. Okay, so the opcode register this allows carrying out any operation on any register using any addressing mode. So these are the things. Mm, Now PIC has a fewer instruction set because of the RISC architecture. Uh, Now additional to that, we have seen there is a A to D converter, built-in power on reset, and brown out reset features. So this is a kind of a new feature that we will see later on. There is a power on reset and brown out reset function. So brown out reset feature, when the power supply drops below certain voltage, it causes peak to reset. Okay, one is this our regular reset, and this is like, so if you see when this will reset, like in your mobile phone, when the battery level goes down below certain percentage, it will automatically shut down first. Below some 15% of battery, it will uh, try to save power. It will go to the power saving mode, and after that, if the battery is not getting charged, it will switch it off the mobile phone, that now battery is about to die. Same way, uh, since this cannot control battery, this much capabilities are not developed, what it will do is that it will reset to itself. Okay, so it will try to see what is happening or below that level, but uh, that means you need to have a constant power supply. Okay, if your power supply is not good, it will continuously do this resetting, brown out reset, because first it will power on, and the moment it will check that power levels are below certain voltage, it will have. So you can see it can have a small voltmeter kind of thing in that, which is measuring the voltage of the battery. If it is not up to the mark, it will try to reset it. It uses a low cost RC circuit or quartz crystal or a ceramic resonator for oscillating frequency clock signal. Many of the manufacturers are using only quartz crystal because the frequencies are also, I think, 16 megahertz or more. The oscillator options are EEPROM selectable. Okay, so means you can program the frequency of the operation. Uh, and you can select. So the first line itself is telling that you have a choice of selecting the frequency. Somebody was asking overclocking, I think from this class or different class. Overclocking, so when you change the voltage levels, the processor's frequency can be increased at the cost of damaging the processor or the transistor, right? Because there will be lots of regeneration. So without proper cooling, if you try to overclock the processor, the thermal switches will switch off the processor. So here there is a allowed range of frequency. So and this means you can program that. Otherwise, you have a other choice that you can connect this a fixed frequency oscillator. That frequency can be very high or very low. What will happen that it will perform the same operation. Anyhow, it has, once you give the command, it has to work on the clock pulse. So if the clock pulses are arriving very slowly, automatically it will function in that speed. If the clock pulses are very fast, it will work very fast. Okay. Only the EEPROM can also manipulate the speed. So you can connect very high speed clock within the range of the frequencies allowed by the PIC. And then using the EEPROM, you can make it is a mode 2 counter or mode 10 counter kind of thing. So you can slow down the clock speed. So counter programmable counter if you have. So mode 2 counter means it will take 2 clock pulse and make it as a 1 clock pulse. Okay. So it will divide the frequency by half. Okay. That is the idea. It supports power saving sleep mode, the clock frozen and all data preserved in the memory, and a software command is used to enter in this mode the peak will be in sleep mode till it reset again. Okay, so here reset means we don't want to load all the files, but it is kind of a freeze mode. This is what in your mobile phone you have. It has automatic sleep mode, so it switches off the screen, and unless and until you press the power button, what will happen? So this feature is there. After that, it is embedded in the ARM processor. Means uh, this is a feature available in the PIC, and then when you have a advanced RISC machine, so it is also using the similar operation that you see when you are not using mobile phone. uh, Automatically it switches off and it locks itself. Okay, so you have to unlock it. But it will unlock only when you press the power button. Okay, so when we say reset, in a crude fashion, reset is means you are restarting the machine in case of computer. Okay? But in case of laptops, now the laptops which are in the sleep mode, you press the power button and they will load the files into the RAM, and then it will work. But in the background, what happens? That it has its page file system, so it creates a page file. Okay, means it is a what we say mirror image, whatever is going on into it, or sometimes hibernation features are there, right? So when the machine goes into hibernation, when you switch it on, it will load the files, it will load the software which was running previously. That image is there, and then it will begin from the that moment. Okay, it will not start the window, it is loading, that message will not come. Instead of that, it will load these files. If something is going on, so it freezes that. This is hibernation. So but it takes lots of time in case of machine computer, but for the mobile phones it is very fast. Peak has a watchdog timer that we have seen earlier also, uh, with the on-chip RC oscillator. Okay, so the resistor and the capacitors are fabricated on the IC itself. It's simple. All the FATE are having both the things um, which makes a field effect transistor. Okay, so there is a capacitor also, and the channel through which the carriers flows, holes or electrons, has got resistance. So only using these two parts or two wires of the transistor, either you can use it as a resistor or a capacitor. Okay, so drain, source, and gate. Which pin you are using, that will decide whether you are using capacitor or the resistor. And then you have a oscillator. Okay, the watchdog timer prevents the peak from endless hanging condition. The same function is there in the 8051 also. So endless hanging condition means it is just rolling or going over the same address and going in. So if this thing happens, the watchdog timer will reset the peak instead of going into the hanging. Uh, Means it is carrying out certain process, and then you notice that it is remaining over there. It is reading the same memory location. It is trying to do some operations, and then again it jumps to the same this thing. If the programmer is not setting any loop, okay, if the programmer has set some loop, then it will work. It will not notify or it will not consider. But if you do not set any loop, and this program automatically runs into that situation, in that case the watchdog timer will reset the peak microcontroller. So which loop functioning on the system with respect to time. So I just last time gave you the example of monostable multivibrator, uh, that when you trigger it, it goes to the one stable state, and then after some time it has to come to the ground state. Now RISC architecture is such that it takes only one machine cycle, we say, to finish the operation. So how much time duration is required to complete one machine cycle uh, is the timing assigned to the watchdog timer. So when the instruction is being executed, the watchdog timer is also going into the stable mode. And then when it goes to the stable mode, means from the higher order to the lower level, if the instruction is not executed while coming, the uh, down going edge will trigger the reset. Okay. Otherwise, if there is a loop, the CPU will again apply the trigger to the watchdog timer to extend its unstable state. Okay. So for us, uh, it may be a little bit difficult that how CPU is going to do it, but it is again the transistorized uh, connections which keeps this watchdog timer to go into a stable state if the loop is set up. Okay, so there is a feedback loop. So ultimately all the transistors and the oscillators are assigned or connected in a such a fashion that this thing will function automatically. The watchdog timer resets by the peak periodically. So this is what I am telling you, that when the operation goes on, uh, the peak controller will reset the timer. Okay, it will reset means it will keep on giving the trigger so that the watchdog timer will remain into the stable state. Okay, and when the function is means when the in the normal process of or the normal operation of the peak, the watchdog timer is continuously reset by the peak. If peak fails to reset the watchdog timer, the watchdog timer will reset the peak microcontroller. Okay, so its behavior is like some sort of enemy. Okay, that if the peak is not prohibiting the watchdog timer from its function, then this is going to attack on the peak and it will reset. So to avoid that situation, peak has internal wiring based on the instructions execution of the instructions that it continuously reset this. Now whatever I'm telling is clubbing two things. One is the software part, okay, means the behavior of the microcontroller, and the hardware part. Now monostable multivibrator is a hardware, okay, but when to trigger the unstable a stable part of the monostable multivibrator is depend on uh, the person who creates the monostable multivibrator, right, or the clock which is connected to the monostable multivibrator. So manually, if a person who knows now I want to make it unstable, so I can trigger that. Okay, so this is what you have to understand. If not by faulty condition, it reset the peak. So you see the relation. Peak is resetting the watchdog timer in a normal operation. If peak is not able to reset the watchdog timer, then means watchdog will understand that there is something wrong going on, and then it will reset the peak. Okay, so peak has 12 interrupts. These are independent. The operating voltage range is just the information, 3 to 6 volt. Power consumption is very low, right? That is one thing that also you can. And it takes less than 2 milliampere at 5 volt and 4 megahertz oscillator frequency. So it can go to higher frequencies also. It's not necessarily 5. Some can go to the further higher. But these two parameters which shows the power consumption is 2 milliampere at 5 volt. So kind of a overclocking if you see below 15 microamperes. Okay, this is milli and this is 10 is to 3 times lesser. 15 microampere at 3 volt and the speed is 32 kilohertz. So if you apply 5 volt it will work with 2 milliampere of current. So, and this is made up of CMOS. Okay. So, but when you configure at 3 volt and this lower frequency, you will see the same operation will take longer time. Okay. So, if you want to do some simple multiplication at 3 volt, it is going to work with very slower frequencies. So, it will take some time. But at the same time, when you go with 5 volt, it will take lots of current and this. So 5 into 2 milliamperes, 5 volt into 10, you can say 10 microwatt power. And there is a, sorry, 10 milliwatt power it is going to consume. In case of 3, this is a 45 microwatt. So 10 milliwatt and 45 microwatt. You see the difference of the power consumption. Now, so it has a work peak uses the W register. This is a working register. So now there is a watchdog timer. There is a working register, and any one of the RAM file register used for the operation. Okay. Uh, Now, still the manufacturer can means what we see is that it is free to use any register, any part of the RAM, uh, but the manufacturer will give you certain instructions uh, that what are the things you must follow for the smooth operation of the PIC. So mnemonics are in the lowercase later, and the RAM variable and special registers are uppercase later. Okay, so when you have a capital A, capital B, then we can see it is designating to the register or the special register. Otherwise, if small a, b, c, d, it can take it as a number or a value like 0ah. So mnemonics are in the lowercase and other variables in the uppercase. Now I will not go with this because this is the example they have given for the program where lower and uppercase how they work. Then this increment decrement is a kind of instruction set or the idea about instruction. So you have instructions are in INCF and DC, decrement encryption instruction, special register, and the store value in either W or F. Okay. So port A, F increment port A by 1. So there are 4 ports A, B, C, D we have seen. So this is related to the instruction regarding increment and decrement function. Okay. Um, Again, there is a output and input instruction. So let me see. Are we supposed to see instruction addressing modes? Okay, so there little bit we have to see how the instructions are behaving, and there will be around 30 to 30, sorry 35 instructions to minimum 35 instructions for the instruction addressing mode. Then it will go beyond. Uh, that we will see later on. So hopefully I will try to see that all the instruction 35 instruction and their meaning. Uh, Even these instructions are grouped such a way that some instructions are associated with some arithmetic operation, logic operation. Certain instructions are associated with transferring the data from memory to the registers. Okay. Certain instructions will associated with the clock pulse counter timer, D2A converter. Then what we have communication with the serial using the serial ports. Okay. So um, this way out of all these 35 instructions, they are grouped into different categories. So if you remember the category, you will understand that this is the role of this instruction. Okay, there may be some sort of special instructions. Probably comparing command is there, or converting it into its complement, or some instructions like reading flag, uh, or writing some instruction into the flag where you have a bit addressability. So this way, only carefully we have to categorize. It is not required that you should mug up or memorize all the instructions. And I will also not focus on asking question like write the program and then you remember all the instructions and write the program. The thing is that in this all syllabus, I am focused on uh, creation of algorithm and the flowchart. That is the most important. If you are appearing for the practical exam and if you are having the things, then the data sheet or the that chart will be provided, mnemonic, machine code and opcode. Okay. But you must know the instruction and the role or the meaning of the instruction. So once you read it, you will be able to see that I want to transfer data into working register or the register A, B, C, D, or I want to transfer it into the memory location. Okay. So that part you will have to uh, just keep in mind. Okay. For our syllabus, because all these two units are focused on the microcontroller, microprocessor, and the architecture. The rest of the two units are focused on the power supply and the additional peripherals. So it is very easy that how the low pass filter is working, what is the communication method, how the devices for the communications are fabricated or designing of that, choice of frequency. Okay. So the moment you go through the syllabus, you will realize that the last two units are also very easy. There will be certain circuits that you have studied in your BSc using op-amp and other things. Even I used to skip all these things because you are doing already in the practical. So you are getting hands-on training on all these things. So you will have a better understanding. This is kind of a hidden part because all these things are there. We write only program. We don't know what is happening inside the microprocessor, microcontroller, and therefore we have to make sure that how even the timing diagrams that we are not studying, when we give individual instruction on the timing scale, how it is decoded, then it is executed. Okay, so whenever any instruction is given or written in, when you write the program, uh, then the CPU will read the instruction from the memory location. But once it reads, it is not necessary that CPU understand the meaning of instruction. We write instruction in our language. That instruction goes into the decoder. Decoder converts that instruction into 0101 string, which switches on and off different flags, different register, different transistors, or different logic gates, and then uh, it will start manipulating the data, and then it will again store the values into the register. Now, what will happen when we try to read what is mentioned? It is only 0101. We don't know the meaning of it. So it has to be encoded again. Means there is a decoder, there is an encoder. Okay, so that 0101 is converted into the user understandable language. And then we see that, okay, this is the result. So when I write 10 plus 10, so 10, I am telling that I want to add two number. 10 plus 10 is decimal number. But in the machine, when it goes, it has to be decoded as 8 plus 2. Okay, on the binary scale. And then it has to be added by the full adder. When it gives me a result 20, means I that machine has to notify me that in a hexadecimal scale, I can have only 0 to 15, 0 to F. So 15 plus 5, that will be the answer. That will be shown as 20. Okay, it will store 15 in one register plus 5 in other register, and then this total is 20, so that has to be encoded as a 20. So uh, this way it is going to work, and people have done all this homework and they have developed the system by considering all these difficulties. Okay, so there is always some improvement, and we have a working system, so it is a kind of a foolproof working system. So we have to also understand from that perspective, and once we understand, we can create our own system. As I told you earlier, that uh, compilers are having language English or some other, but why can't we have our own language compiler? Say in Hindi I want to write program, the compiler must be able to understand. Okay. um, like in mobile phone there are some languages are given, so why can't we write program in our own language, which is very simple. How can we modify the compiler to work in our language? And if you can do it, many people will be able to write program very easily. The way we have instructions on ATM or some smart ticket vending machine. So if you choose the language Hindi, they will start speaking Hindi or Marathi, English. So, so these are the instructions. This will be the kind of a task in future, where nowadays people are forcing that as the fifth standard, sixth standard student to do coding. Okay. So but to do all these things, your logic must be clear. There are many people who can write program, but they have just mugged up the program. Not unless and until the logic is clear, it is difficult. So, anyways, there are three I/O control registers: TRIS A, TRIS B, and TRIS C. And these registers are loaded with content of the regular register W using instruction move LW and move W. Now, these three I/O control register, TRIS A, TRIS B, at a time you can only make use of only one register. That is the thing. Okay. So if you are using the operation with TRIS A register, then you will be continuing only with the TRIS A. If you have chosen with TRIS B, then it will work with TRIS B, and TRIS C, then it will be only TRIS C. Okay. The benefit of this is that in three registers, you can set up some three different conditions. That if you are working with TRIS A register, in TRIS B or TRIS C, you can store the necessary things which are required for the standby mode or for the sleep mode. Okay. So when the processor goes into sleep mode, it will load the instructions from this register. Or if it is in standby mode, it will load the instruction from this register. Okay. So TRIS A, TRIS B, TRIS C. And in our ARM processor, similar set of almost eight different flag registers or stack pointers are made up. Okay, so each stack pointer section is storing the necessary address and the instruction required for that working mode. So there is supervisor mode, power saving mode, user mode. Then there are other few modes, and for the each mode, the instructions are stored in a particular stack. Okay, and the starting address of the stack, from that the program counter associated with that is also reads the next instruction in that. Okay, so sleep mode, standby mode, power saving mode, reset mode, user mode, supervisor mode. This is a variety of things which we are going to see in our process. So these registers are you can use the one register at a time. That is the main thing, and other registers can be fixed for some other operations. So there are certain instructions. I will not go into the much detail of this. This we will see later on. Three interrupts are supported by 16 C6s. Um, Means there are 12 independent interrupts, but they are categorized in this external interrupt, timer interrupt, and port B change interrupt. So along with that, the improvement in this case is that in previous case we have seen interrupt enable has to be there if you want to sense the interrupt. Okay. Otherwise, the 8051 do not sense any external interrupt unless and until the interrupt enable is set to 1. Here, PIC will require two different bits from int con for any interrupt operation. Okay, means it requires two different bits. One for enabling the interrupt, one for its detection of the occurrence. Okay, so what will happen that in the flag register, one bit is going to enable the interrupt, and second one is detection of the occurrence. Means what will happen if you disable this interrupt acceptance signal, means interrupt enable, if you disable it, and if you just enable the detection of the occurrence, what will happen that the CPU is not going to sense any interrupt. If you enable the interrupt and if you do not interrupt the detection of the occurrence, again the CPU is not going to sense. If both the bits are enabled, okay, interrupt sensing means interrupt enable is set to 1, and the second is detection of occurrence is set to 1, then and then the PIC microcontroller is going to listen to the interrupt, right? So that is the advancement over the its previous microcontroller. So this is gate, I think GIE, so I interrupt enable. G is for gate interrupt enable or something to enable or disable all interrupts simultaneously. For interrupt, the GIE bit in the incon and the corresponding interrupt enable bit must be set. Uh, the thing is that a programmer can write program and then clear the GI. Okay, that interrupt enable means it is in the hand of the programmer to enable or disable the interrupt enable um, or the interrupt section of the CPU. After reset, the GI bit is cleared and all interrupts are disabled. Okay, so when you do reset, what it does along with loading the program from the memory location 000, it also clears the flags, various flags which are enabled. So somebody asked me that now why we are using 8-bit or 16-bit or 32-bit processors, because of the safety, and secondly we have seen here, as I told you, there are certain flags which can be set and reset by the programmer. So these flags can be set or reset unless and until somebody puts the password. Okay, so that string is also written in the memory. Then one has to input the proper password with the proper capital, small letter, and this. Then and then the things will work forward. Okay, so even in our PC, there are certain software which keeps on monitoring the flag register of our processor. Okay, and if you when you run any program, they will just tell you the registry or the entry in the flag register. Okay, so for us, we are working on Windows environment, but in the background, when we talk about processor, the processor is functioning with only the flag registers and different registers and these interrupts. So the status of all the registers and the flags can be sensed by the the software, and they notify you. So if you are running some program, there is a capability in this software that they can run the program for you. And if it is password protected, it will tell you that these flags are set or reset. And the moment you put the password, it will show you that now the flag is changed, and now you can run the program smoothly. Okay. If there is a password which is not proper, okay, if it is denied the password entry, then also you can come to know that okay, this is what happening with the flag register. Okay. So uh, people who are more curious how the softwares are working on Windows environment or Linux environment. Basically, for Windows environment, there are some debug softwares. Okay, even your Windows VC++ has got some debugging things, but I have not seen the registry information available in VC++. But there are certain softwares where you can see even small software. Suppose you write some a program in C++, addition program, you get some exe file of it. You run that exe file through that software, and then you can check that how the CPU is behaving when you give two number to add. Okay, how the flags are set and reset. Okay. So you can have a better understanding of the flag reset. Now all the processors that we use like Intel and all these things in different operation like space ship and other things, um, people are creating different cards. Okay, like we have a LAN card, we have a sound card in our laptops or PC, graphics card. So on each card, people put all these microprocessors like Intel high-speed 3 key cards, and then each card is programmed to do specific function. Okay, and then so you can see that the single processor we use it at our home for our computer. For the more complicated system, big machines like rockets, satellites, uh, hundreds of such processors are used to finish a particular task, and they are programmed, and then they are controlled by similar kind of processor. So there is no display and there is nothing, only memory. There is a program. That program is fed to the processor. In our laptops, what we do is that we feed operating system so that we get a display and graphics and all these things. So what kind of programming understanding you need to have when you are working with all this processor with millions of transistors. Okay? And people are doing so, you can do it. It is not difficult task. If it was difficult task, nobody would have done it. But with time, people understand. Right? The way you learn driving the bicycle or motorbike or car. Initially, these are like very difficult job. How I'm going to control steering, how I'm going to pedal, how I'm going to control the brake, clutch, and all these things. But uh, in 10-15 days, all the difficulties are going out, and then you can run all these devices very easily. Same way, you have to sit for 10-15 days to understand. That is the thing. So interrupt logic diagram, this is what they have shown. TI off, TIOE, intf, int E, then RBIF and RBIE. So these are the interrupts. There is a AND gate connected. So AND gate will give one only when both the inputs are one. Okay. Then it is connected to OR. So any one interrupt that comes, additionally this will be also connected with some other thing. So gate enable is a basic AND gate. If it is not enabled, it will not going to give you output. There is a wake up if in the sleep mode. Okay, so gate this interrupt enable pin is always one. If these are not working, but the processor is in sleep mode, then you can have additional input called as wake up, so that is going to wake it up. If the processor is performing certain operation and some interrupt is coming, like when you press the button of the left, okay, or you want to enter something from the keyboard, and if you press the keyboard button, so then it will have that particular interrupt coming. uh, this is clubbed together through the OR gate, and then this is enabled, and this OR gets input. If both are 1, then it is going to the CPU. If it is not, CPU remain means it will not notice any interrupt coming, because if this is disabled or any one from this terminal is disabled. Okay, so this is the way the interrupt works with uh, two interrupts which must be enabled in order to notify the CPU. So previously we were discussing only on the software level, where you have to imagine that how it is going to work. Now you have the actual working image in front of you. This is showing you that, because you know very well what is and or and gate, but within this AND gate, you know there are 6 to 7 transistor. This has a 6 to 7 transistor that you have studied earlier. So now you are not going into that much deep level. So this box tells us that it is made of 7 transistors, and it is telling you that when both are 1, you are going to get the output. Okay. So this way we have to assume that how the compare statement is going to work. In compare statement, there will be 2 numbers, but 3 outputs. Here you have many inputs and 1 output. In compare, there are 2 numbers, A is equal to B, or A is less than B, or A is greater than B. Okay, so you are giving 2 inputs only, but in the output section, you are having 3 different things. A is greater than B, A is smaller than B, and A is equal to B. Okay, so when the same condition is achieved, your XOR or XNOR gate behaves in different manner. XOR gate will give you 1 when both are 0 or both are 1, right? So, and the and OR gates are there, where any one situation is satisfied, it gives you this. So this way people with smart uh, thinking, using these logic gates, they have created the comparing gate, okay, which compares 2 inputs and 1 output. uh, we are not doing all these practicals, but I would have given the experiment also, that just studying the NAND or AND or gates. Let us utilize all these gates. First check the gates and then utilize them along with the adder subtractor functioning. Let us make something different called as comparator, and then you give some two values, 0 1 1 0 1 1 0 0, and see what is the output that is being given. Maybe on laptop I can share some app where you can use some logic gates, and you can connect them and you simulate. Okay, so this simulation, electronic simulation app, you can test it, and then you can have some screenshot that's this is what I did, and then at the output I have kept some LEDs, so they are glowing on or off, and they are indicating whether A is equal to B, A is less than B, or A is smaller than B, A is greater than B. So these are the things. Then there are different interrupts which are categorized in this. Int is the interrupt due to the external source. Transition at pin PB0 in causes this interrupt, and this is an edge sensitive interrupt. Okay, so when you have edge triggering, it will sense this interrupt as rising edge trigger or falling edge triggered by configuring the bit in option register. So additional information that main thing is that it is edge sensitive, but it is rising edge or trailing edge, um, means that has to be programmed in the option register. Okay, and then the register associated to program this is also mentioned int G. When there is an interrupt at pin int, the NFB bit is set to int. So now how the interrupt section is working, that is being discussed. We can just have a little bit info because I will stop in say 5 minutes. Uh, so this interrupt section, how it is working, then interrupt bit must be reset to interrupt service routine. This interrupt awake the processor from the sleep mode, and when um, this happened when it is enabled before sleeping mode. So um, here we have seen in the diagram that is also giving you the idea. If the interrupt enable is not one, then either you give the wake up signal or any interrupt coming from this, the CPU is not going to listen and it is not going or it is not going to awake, okay, from the sleep mode. So you have to first make sure that this is enabled, and then other interrupts will be considered. That is the overall justification which is mentioned in how the things are taking place, what things you must in one go must be enabled to wake the PC. These things we will see later on. I will notify you when we are supposed to do all these things. Maybe next week, I don't know. I may be able to take your lecture or not. I will notify you. Uh, Timer interrupts and all these things. Meanwhile, you people can just take that I have asked you to create some column, and then you write uh, in one column you keep some properties. First column will be the properties, and the other columns will have 80, 85, 89, C51 and 8 mil and PIC microcontroller, and then CPU flag register, working register. You, so in these properties we'll be having the keywords: size of the memory, uh, processor bit, data bit, instruction set bit, all these things. And if you tabulate this, um, what you will have to do in the exam is that you have to remember that table only. Okay. So once you just see that particular table, you need not to read all these things, how these fellows are working, इसमें क्या है, उसमें क्या है. That table is going to help you memorizing everything, and in future also you will be very easily recollect all these things. So this is kind of a method of memory mapping for all the processor, and then when you are working in that particular thing, uh, then automatically you will get